Hello, my name is Muhammad Akmal bin Zaidi, and I would like to brief some our introduction. As we know, a Petronas tower is the world's tallest twin building. So the task application is on stainless steel mechanical properties and its structure. And we are consist of five members, which is me, Muhammad Akmal bin Zaidi, followed by Hazma bin Hazaini Muhammad, second one Muhammad Nur Hakim bin Umar, one Irfan Syami bin Warzaini, and last one is Muhammad Haikal bin Izani. So our company name is H&M Company, where we are able to identify formulate, and analyze complex engineering based on its structure for any specific application.
Assalamualaikum warahmatullahi wabarakatuh, Prof. My name is Muhammad Rakim Umar, and now I'll be start presenting our objective and problem statement for the assignment. Okay, there are two objectives in our assignment, which is first to show the performance of a normal 316L stainless steel and a cold rolled 316L stainless steel to the client based on the tensile test experimentation using available standard test method. And the second objective is to propose a possible strategy in order to modify and enhance the mechanical properties of the 316L stainless steel material. Moving to the problem statement, there are also two problem statements in our assignment, which is first, what is the difference between a normal 316L stainless steel and a cold-rolled 316L stainless steel based on its performance in tensile test experimentation using standard test method. And the second problem statement is, based on the raw 316L stainless steel material, how can we modify and enhance its mechanical properties? Okay. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Haikal bin Izani. Number of matrix B022110079 will explain about a technical finding. Throughout the analysis have been done, there are three graphs have been plotted to get the data. Firstly is a stress strain curve, second is a linear graph, and third is offset graph. Firstly is a stress strain curve, which has been shown is a stress strain curve for original 316 LSS curve and stress strain for cold roll. Firstly, to get the value of stress, which is by a formula force divided by a cross-sectional area, and strain, which is the displacement over by gauge length. Okay, next is a linear graph. For a linear graph, this is to find the modulus of elasticity value, where for the cold roll is 206297, it is a modulus of elasticity, and 212137 for original. The value of R square is to get the accuracy of this graph, where is near to number 1 will be more to accurate for this graph. Next, for offset graph. This offset graph is intended to get the value of yield strength for each of material, where is a blue line for a stress strain curve and red line for a offset. The value of offset has been obtained by calculating which using a modulus of elasticity value. The value of yield strength can be said when the intersection of these two lines have been met, where for the stress strain cold roll is 975.915 megapascal, and for original is a 265.452 megapascal. And lastly, for the obtained data, have been compared where is a tensile strength and between original 316L stainless steel and cold rolled 316L stainless steel. For the tensile strength can be see that a value of cold roll is more higher than original, The tensile strength can be calculated by a formula of stress where each is a maximum force of have been applied to object divided by a sectional area. We can get this value and the modulus of elasticity from the linear graph, and ductility is a final value of the material before its fracture, and offset which is have been set 0.2% for each material, and yield strength which has been obtained from offset graph. That's all from
My name is Wan Irfan Syahmi Muazaini, and I will explain about the relationship between microstructure and mechanical performance. The microstructure of a material such as metals, polymers, ceramic can strongly influence properties such as strength, toughness, ductility, hardness, corrosion resistance, high or low temperature behavior, or wear resistance. As we can see here at the table, the size of the grain for original sample much bigger than cold roll sample. The particle that move along of grain boundaries is faster. This condition will make dislocation harder to occur. So we can conclude that cold roll sample are much stronger and tough compared to original sample. But as the strength increase, the ductility will be decreasing. For mechanical performance, it is also used to help classify and identify material. The most common properties considered are strength, ductility, hardness, impact resistance, and fracture toughness. Most structural materials are anisotropic, which means that their material properties vary with orientation. The smaller grain size will make more boundaries exist. When more boundaries exist, more obstacle to dislocation motion will happen. This condition will make the material higher in the term of stress and tough, but the ductility will be decreased as the strength increase.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hazman Bihazani. So today I'm going to present to you about our assignment, which is stainless steel mechanical properties and its structure for 316 LSS original and cold steel. In a conclusion for this assignment is 316 original sample has a core structure due to its large grain size, and it has austenitic stainless steel face structure composed of ferrite and austenitite face. The original 316 sample has a low dislocation density. The appearance of strength in ferrite is a roll sample of 316 LSS will result in partial martensite transformation as the austenitic fraction decrease in a microstructure. The fracture structure demonstrates a high dislocation density, and grain size decrease proportional as dislocation density increase. The hardness and mechanicability of the material increase, so we want to use 316L in a twin tower application. In order to improve its mechanical properties, we must core roll it, and to further improve the resistance of the residual stress, we can use the heat treatment on the body in the body to improve the overall strength. Heat treatment are method of change the physical properties of metal and improving the suitability for its use in variety of industry by using control heating and cooling procedure. Material are heated to the desired temperature and held there for a specific amount of time before being slowly or rapidly cooled down, depending on the type of materials, and the process refine the grind microstructure, making it more uniform and workable. It is also used to improve a material ductility for further machining and to reduce casing stress. Thus, core roll 316L SS is the most suitable because it low cost and much more better improved stainless steel. That's all from me. Thank you.